Okay, hello, hi, this is Rani Ahmed with you, and this is lesson 16, how to program using Haskell programming language. And in this lesson, we're going to talk about pattern matching. Now, just to remove the confusion, this is not regular expressions. Okay, this lesson is not about regular expressions. And if you don't know what's regular expressions, I just have to highlight it a little bit. Okay, regular expressions is just when I have words which share, for example, the letters AT, okay, and you want to find all the words that end with AT, okay, or has the letter AT, and you want to make an expression that will allow you to search for those words, okay. Now it's not confined, or it's not just restricted to AT, it's generally to any strings, and it's a big topic, okay. There's some time maybe we can cover it, okay, and you can find it, of course, anywhere online. It's a very important topic, but this is not pattern matching, okay, as it's concerned to Haskell. Pattern matching to Haskell, or with respect to Haskell, is how, for example, if I take a function f, okay, and you know there's x and y, so how I can match x and y on the right hand side, okay, of the equal sign, okay, or the equal operator. Cool. So it's all about finding where x and y inside the function. For example, if I take something called as patterns, okay, this is as patterns, and as patterns is, for example, I have this totally those three words, x and y and rest, okay, with their cons sign, constitute a list, okay. Now, if I want to find something that matches the whole thing here in one word, I can use the word list with the character at in front of this, okay, and this completely here, all what I'm highlighting is one input to the function m, with m taking another function f, okay, and this is the function f here, okay, and the function here f is supposed to take two parameters, okay, x and y. So this is where the pattern matching comes, okay. You're matching the existence of y and x from the left hand side of the equal sign to the right hand side of the equal sign, okay, of the function. So just to refer to the whole list, okay, in one word, because this otherwise I will have to define x and y and rest here, okay. It will look ugly a little bit, so it's better that I use a variable here, list at, okay, and at means you're saying that I'm using the list which is the same as the x cons y cons rest, okay, and rest here refers to the rest of the list, okay. So and because f takes two parameters here, x and y, I must always check whether the list that has been input, okay, or the input list, this one here, okay, it will be even a number, okay. If it's not, I just throw out an empty list, okay, because I'm not able to calculate the list when it's odd input, okay, because I want to take every two in this list. Now, another thing here is something called records, okay. Remember from previous lesson that we were talking about constructors, okay. So we were talking that, for example, if I have like a data type called celebration, okay, and you know, we can define so many constructors like what we have here, but in the previous lesson we were talking that you can define a constructor, for example, called wedding, and it takes two parameters. The first is a string, the second is an integer. Now this time, using records, we can just not keep it dry like this, okay, not knowing what would be a string here and what would be an integer here. Cool. So we can just make it like this and say, for example, the first thing is a name, okay, and it's of type string. A second one is a cost, and it's of type integer. Cool. And the same is for the rest. So if I want to define a variable, for example, variable p, which is celebration, which can give me the constructor wedding. So the p can be a wedding, and I can set the name and the cost as such. I can do the same for with respect to the birthday and this fiesta. Okay. Now regarding v here, see, I have an empty sorted list. Okay, it's with this braces. Okay, curly braces. This means that the wedding is not initialized. Okay. So v is not initialized as a celebration. Okay, so this is what will Haskell give you. It's a warning when you compile. Okay, so wedding is not initialized. Next is, after the records, look here, we have, for example, I want to print O, but O is t plus 5, but I don't have t. Okay, so what's t? T, okay, is the head of whatever the list is, okay, because you're using the underscore. So underscore means whatever or anything, okay, and you know, map should give you as a result a list. Now map here will multiply every element of the list 1, 2, 3 with the number 2, okay, because you will consider the multiplication as a function here. So map will give me that list. So if I multiply by 2, the first one will be 1 times 2 will be 2, okay, but you're saying t is the head of the list and whatever the rest is. So when you substitute here, okay, t will be 2 and 2 will be substituted in this t, so it gives you 5 and it gives you 7 because of the addition of 5. So this is how I print O, okay, and this is the result of O, okay, with the number 7, and here's at the bottom printing, or use put string line to print O. Cool. Now next, what if I just want to grab the first character of a list, okay, or a string, I mean, from the keyboard, okay, when I input things on the keyboard at the terminal. So put a first char, okay, will be an action, do get line and put string line c. So similarly what I have done with t here, I'm just grabbing from the get line, which is a string, okay, which will give me a string, okay, and the string is already considered as a list of characters. So because of this consing I'm using, it will give me c, okay, and you know, I can print then c only. I don't have to print the whole list. Okay, so this is the first character. So see what else I have missed. Okay, so that's all. Okay, thanks for watching. Just please subscribe to my channel just to keep up with the updates. Okay, and thanks for watching. Bye.